This video is on Euler circuits and Euler paths. This is Shannon. An Euler circuit has two rules. One, it travels each edge only once, and it ends back where it began. An Euler circuit must have only vertices with even degrees. Some examples of uses are for mail delivery, trash pickup, school bus routing, and street sweeping. Please realize it will travel each vertex several times possibly, but again, it travels each edge only once. Pause this video if you need to copy some notes. Okay, so in our first example, we have a graph drawn. Notice we have vertices A, B, C, D, E, F, and we have many edges. To decide if an Euler circuit is possible, I'm going to count the degree of each vertex. That is, vertex A has 1, 2 edges coming out of it, so vertex A has a degree of 2. B has a degree of 4. Vertex C has a degree of 2. Vertex D also has a degree of 2. E has a degree of 4. And vertex F also has a degree of 2. Please pause this video and confirm these degree counts on your own. Because each of our vertices has an even degree, there is an Euler circuit possible. Let's look at our next definition. Oh, I'm sorry, there's an error here. This should say Euler path. I apologize for that typo. An Euler path travels each edge only once. Notice there's only one rule here. It doesn't have to start where it began. It just has to travel each edge one time. So, to have an Euler path, we must have 2 or less vertices with odds. Remember, the Euler circuit, we had to have no odds, only evens. For an Euler path, we must have 2 or less odds. So let's look at the example we just did. Do we have 2 or less odds? Yeah, we definitely have less than 2. In fact, we had no odds, which means an Euler circuit and an Euler path are both possible here because it fits both rules. Rule 1, Euler circuit needs 0 odds, and an Euler path needs 2 or less odds. So both of those are possible here. Let's look at our next graph. Pause it to draw it if you want. Again, I'm going to count the degree of each vertex. A has 2. B has 1, 2, 3, 4 edges coming out of it. E has 2. D has 3. And C also has 3. Notice we do have some odd numbers here. C has an odd degree, and D has an odd degree. Since there are 2 or less, an Euler path is possible. An Euler circuit is not, but an Euler path is. So now I want to look at a couple more graphs. I'm going to do an example, and then I ask you to pause the video and do the next 3 on your own. In these examples, in these problems, I don't have our vertices labeled, but I can still count the degree of each vertex. 1, 4, 3, 2. I'm going to count how many odds there are. Remember, for an Euler circuit, there must be no odds. For an Euler path, we can have 2 or less odds, and it will still be possible. If we have more than 2 odds, neither a circuit nor a path are possible. So in this example, notice we have 2 odds. Because we have 2 odds, an Euler path would be possible. For each of your 3 problems below, you're going to just say whether an Euler circuit, an Euler path, or neither is possible for that picture. Thanks for watching.